Hello, calculus students. I'm here to tell you that calculus is very important in your everyday life. From the moment you walk or drive to school to the time you turn on your computer at night, calculus is embedded in the forces and devices that surround you. The first part of calculus that you will be introduced to is derivatives. Derivatives are the basic foundation that will be seen over and over again in your calculus and engineering applications. Engineering applications of derivatives can be seen all around you in areas such as kinematics, fluid dynamics, metal structures and properties, architecture, and even radiation. One of the most common applications of derivatives is determining rates of change. Rate of change is important because it tells us how quickly or slowly a value is changing, and we can use this information to predict future values or behavior. The reason derivatives are so important is because they help describe nonlinear rates of change that cannot be explained or modeled using traditional algebraic expressions. Mechanical engineers commonly use mass spring damper systems to model complex systems whose behavior would be impossible to understand otherwise. For example, in order to properly understand the distance and g-forces a bungee jumper would undergo, mechanical engineers have to model the behavior of the bungee cord via corroborating experimental data and using a mass spring damper system to predict the elements of interest of the jumper. Commonly, engineers face problems that they cannot see or visualize. Instead, for example, petroleum engineers must use models to monitor and predict fluid behaviors in oil wells. Engineers monitor the well pressure, and if they notice sudden and unusual rates of change, it notifies them of immediate problems, such as blowouts. A blowout occurs when there is an uncontrolled release of oil or gas from a well. If pressure control systems fail and safety measures aren't taken, blowouts can prove destructive and fatal. A situation you may all be familiar with where this occurred was the 2010 Deepwater Horizon oil rig blowout. Finally, electrical engineers must use their knowledge of derivatives to understand certain electrical properties in order to tackle the energy challenges of today. Solar panels convert incident sunlight into electricity to serve as a clean and renewable power source for our homes and businesses. As sunlight hits the cells on the solar panel, the energy from the sunlight energizes electrons to move through the material and creates a voltage potential between both sides of the cells. The voltage potential creates a current defined by the rate of electrical charge moving through the panel and into the facility's power grid. This electrical current is then used to meet the power needs of the facility. In this lab, you will study the rate of change of a shadow created by incident light to further understand the need and the tools created by derivatives.